For homework 928, I'd like you to copy all of this work and then the 3 words to show me that you listened to build these repetitions. All right, but again, 4 of the hardest problems on the test. Here I go. This first one, the graph one, I'm telling you, the most successful way I've seen people do this is to write out what those numbers are. When x is 1, I go up to 1, 2, 3, 4, 5. That's that first point. When x is 2, I go up to 3. When x is 3, I go up to 1. Use that as your terms. The first term, second term, third term, fourth term. Know that those top numbers, that's where the pattern's coming from. Looks like I'm subtracting by 2, subtracting by 2. That is my D number. That is my slope. That is the slope that matches a line going through these points, going over 1, down 2, over 1, down 2, matching that slope. I could use that to backtrack, to go to the left, to find that all-important 0 term. So take that 5 and adding 2 gives me the 0 term 7. Kind of makes sense. Instead of going right 1, down 2, if I backtrack up to left 1, it gives me that y-intercept term right there, 0, 7. That is where it's touching the y-axis. That matches the y-intercept. First word is topic. Topic. All right, to write recursive, here I go. Minus 2 because I'm subtracting, don't put plus 2. And then for full credit, get in the habit of writing what that first term is for full credit. For explicit, write it with the number that you're adding or subtracting, that D number in front of X, plus or minus the y-intercept term, whether it be positive or negative. Or shift over 1 to the right and use not the 0 term, but the first term, or when x is 1, look up above, you got y is 5, or f of x is 5. So if I write that one with the shift to the right, that's going to be negative 2, and then in parentheses, x minus 1, and don't use that plus 7, use that 5 right there. And know that eventually we're going to have you know how to distribute, get negative 2x plus 2, and know that that gives me the exact same equation. That's why you could use both. They are equivalent. Make sure on test day for the recursive you give me the first term, or explicit you give me both forms right there. All right, for just a sequence of numbers, here I go. This is the first one, second one, third one. This is timesing by 2. Oh, no, not timesing by 2. Timesing by 5, multiplying by 5. Going to the left, dividing by 5, but we don't show that. We show dividing by 5 as timesing by the reciprocal of 5, timesing by 1/5. So to backtrack to that 0 term here, take that 2 times 1/5. That gives me 2 over 5. That's where I'm getting that y is 0 term 2/5. If I write this in recursive, here I go, recursive. Times 5. Get in the habit of writing that first term 2 for this one. That 2/5 is not the first term. Explicit, be able to write both. So either use that 0 term number times the r number to the x power, or shift 1 to the right and use not the 2/5 but that solid positive 2 times 5 to the x minus 1 power. Second word is view. View. All right, so here we go. Next, for this one you need to backtrack 4, 3, 2, 1 to that all-important 0 term. This looks like I'm timesing by 2. So going up, dividing by 2, or timesing by 1/2. Take this 6 right here, times it by half, or 6 divided by 2, same thing, gives you 3. 3 divided by 2, or 3 times 1/2, gives me 3/2, 3 halves. 3 halves times 1/2 gives me 3/4. Notice that 3 on top is not changed in 3 halves. Second term, 3/4. That 3/4 times 1/2 gives me 3/8. That 3/8 times 1 more 1/2 gives me 3/16. Notice that only the bottom number is being times by that 2 when I'm really doing these fraction problems. So if I was to write recursive times that 2 number, always get in the habit of writing that first term. For this one a little bit harder, that's the 3/8 term. If I was to write explicit both forms, either use that y is 0 term, 3/16 times the r number 2 to the x power, or shift down 1 and use the 3/8 times that same 2, but to the x minus 1 power. For this last one here, and for some reason that's going away, I'm not sure, we'll just leave that in blue. Alright, we'll just leave it. For this one, that 10, that is how much you're putting in the bank. So for this one, really list these terms out. The 0 term is given for this one, $10. That's how much is in your bank after 0 days. After the first week though, I'm adding 4. That comes from this number. That is my D number. That is my rate of change. So if I add 4, that gives me 10 plus 4, 14. That is my first term. Plus 4, 18. Plus 4, 22. If I was to write this in recursive, plus 4. Get in the habit of writing that first term. For this one a little harder. The first term is 14. $10 in that bank, $4 after the first week. If I was to write both forms of explicit, put that 4 in front of x plus the y-intercept term, or shift over 1 to the right using that same 4 but to the x minus 1, and not adding 10 but adding the 1 next to it, that 14. I want you to know that these graphs have special looks to them. Any graph that's recursive and arithmetic is going to be straight line dots. Any graph that's explicit and arithmetic, straight line. Any graph that's geometric and recursive, dots following that exponential curve. Any graph that's explicit geometric, a curve with a line drawn through the dots. Know that. This one up here, this is geometric. This would be geometric recursive. This would be geometric explicit. This one up here is arithmetic recursive dots. This one is arithmetic explicit line. So know that added to it. The third word is puppy. Puppy. Good luck.